out our books. We are recording, and we're going to do the proofs.
Why is that fan maybe so
If you guys were to pick one that you would like done in 4-5, what example would you like done? Yes, Sean.
Number 2.
Right out the gate, huh?
I think I did that one right.
Tell you what I'm going to do.
You just tear it. I don't care.
That is the picture, basically, is it not?
Correct. Yes, it is.
J, K, M, L. It is given to us that JK is parallel to LM. JL is parallel to KM. We're going to prove that triangle JML is congruent to triangle MJK. Believe it or not, this is a pretty easy one.
What number is this?
Number 2.
I feel like I got this one right.
How many steps do you think this one is? Emma?
3.
I got 4.
It could be 3 to 4 steps, depending on if you combine steps or not. 1, you're given that they are parallel, so we're rewriting that. Now, what does that tell me?
That JM is congruent to JM. Because of the common
No, it
side.
doesn't. You cannot, or no.
Common side.
Yes, next I could say, but what I'm going to do is I'm going to go straight to saying, what does it mean to say that these are congruent? Well, or no, I'm sorry, that they're parallel. Look at this picture. With respect to those two, would those not be alternate exterior angles?
Yes.
Or interior, I'm sorry. So I could say that angle KJM is congruent to angle what?
LNJ.
LMJ. And that is because they're alternate interior angles. Now, would these two not be congruent for the exact same reason?
Mm-hmm.
So let's write that down. And since I have the same reason, I can combine these into one step. L, but if you want to make this step 3 and write the same thing again, more power to you. L,
NJ.
J, M is congruent to angle, what would it be?
K.
J, M, K, correct?
Mm-hmm.
Same thing, by they're alternate interior angles. So if you want to think about it, remember, we can use 4, we're going to use side, 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 right? Side, angle, side, angle, side, angle, or angle, angle, side. Right now, how many do I have? What do I have here? I got an A for angle, right?
Yes.
And then I proved another A for angle, so I'm probably going to be using one of those two, aren't I?
Yes. Yes.
Can you look at the picture and tell that any sides are congruent?
Yeah.
They didn't give it to us. Remember, the only ways to tell are usually what? Sides. What's the only reason you can look at a side and say they're congruent? Because of
Angle.
they're a what?
Linear pair.
Linear
Just sides. How can I look at a picture and say two
Common side.
sides? The only way I can just, by looking at the picture, is to see a common side. And that's what that is. JM's a common side, isn't it?
Mhm. So JM.
Of the two triangles, I'm trying to prove congruent. So JM is congruent to what?
JM.
Reflexive or common side. Now I got my S. So I have the three things I need. The question is, which one is it? I know the two triangles are congruent. I just need to, what theorem said it? Triangle JML is congruent to triangle MJK. By what? Well, look back here at your picture. If I was looking at the bottom triangle, everybody looking up here, don't just write this down, please just look, because that's where you get in trouble. I've got an angle, and then that's my side congruent and another angle. With regards to this triangle here, what do I have?
Angle side.
It's angle side angle, isn't it? How about up here? It's still the included side, isn't it? I have angle side angle in that one, so my reasoning must be what?
Angle
Angle
side.
side.
Mr. Stump, can't you figure out if it's gonna be angle side angle before you even start your proof?
Oh, yeah, you could.
Okay.
I mean, and it, probably most likely, you can look at all this in your head and you ought to kind of, you can do it step by step kind of in your head and then just write it down. You know what I mean? That's what I did. That's what I do. I get a look at the problem, I get a plan of attack, I kind of see the things that I see are gonna be true, then how does that come together for what I need?
Are alternate interior angles always congruent?
If they're parallel. Good question.
Okay.
The reason I could say that they were congruent here is because they're alternate interior angles, and those two are parallel, and those two are parallel.
Okay. So that's the only time you would use that, the alternate
Right,
interior?
the alternate interior angles when they're parallel,
Okay.
yes. See, by me stating that they are parallel, and that's a very good question, I was then able to go to this, because the alternate interior angle theorem says that if two lines are parallel and cut by transversal, then the alternate interior angles are congruent.
I just wondered why you used that.
Well, yeah, it's a good question. I mean, I'm kind of jumping through it, trying to get through it fast, but, I
Can
mean,
you phrase that? So,
yes. Yes.
But how do you do number 5 on A?
Well, what the surveyor can do, if he knows they're perpendicular, he can, what the surveyor can do is he can prove that those two triangles are congruent because of vertical angles, right? So you have angle side angle. So what he can do is, even though he can't walk across the river right there, he could find the distance from D to C, and that would have to be the distance from what? A to B, and he can physically walk there and do that. Does that make sense? And then do the other. Now, the second part, what's AB? They gave you DC, didn't they?
yeah.
What's AB? 550? Because they have to be drilled. Any other proofs you want done on that assignment?
Number 4.
Huh?
4. Yeah, 4.
Under 4 and 6.
Okay, first of all, look at 4.
It's basically like number 1 and 2.
And I just wanna go look at this for a second before we go through because we can't do a bunch of them. We look at 4. What is similar about 4? How are 2 and 4 similar
They
here?
both have common sides.
They both have common sides,
And
so you know
parallel
that's
lines.
one of your sides, right?
Parallel lines.
And they both at least have one set of parallel lines. So if I was a betting man, I might look for what first? You got common side. And you might look and see if you have a set of what? Alternate interior angles. Now, what is different about this one is understand this is congruent to that. Oh, well, there we go. This right here is congruent to that. Okay? Nothing says this is parallel to that, so you can't necessarily say this is congruent to that. Just those two. The reason we could do both of them up here is because both sets were what? Parallel. But this is what type of angles? Alternate what?
Interior.
So I've got that congruent to itself and two angles. The only question is it angle, angle, side, or angle, side, angle?
Angle, side angle.
Okay. Isn't this going to be congruent to that?
Yes.
Is the side congruent to one in between the two angles? Or is it the one outside? What would be the included side? You have an angle here. Look at this triangle right here. This is my side congruent, right? Everyone agree? Is that the side in between those two angles? No. Up here, I have two angles congruent. Is that the side in between the two angles? Look up here. Here's my two angles. Is the side congruent the one in between the two?
No.
So is it angle, side, angle, or angle, angle, side?
Angle, side.
Very good. So you guys see what you're gonna be able to do? They give to you that, so you can say the measure of angle G equals the measure of angle J by what? Substitution. And then that makes them congruent. So you've got, there's your A. You can say those two are congruent by what? Alternate interior angles. There's your other A. And then the two sides are congruent because they're what? Common side. And there's your S. And it's angle, angle, side. Right? Did I give you number 6 to do?
Yeah.
I would suggest we do number 6.
What is that? Huh? Said I love that song.
Okay. Number 6. Okay, let's see what is given to us. It is given to us that CE bisects what? Angle BED. That's given. It is also given to us that what? Angle BED, or no, I'm sorry, angle BCE are right angles. And what else is given to me? That's all, right?
Yes.
Our angle B, or not B, but ECD is a right angle. I butchered that up pretty good. I'll have to wait for that to dry. Over here to the left, we're gonna mark down what's given to us. Okay, basically, they said that these two were right angles, correct?
Yes.
What are we supposed to prove? The two triangles are congruent?
Mm-hmm.
We're supposed to prove the two triangles are congruent. Let's look at this right here. CE bisects angle BED. What does that mean?
Cuts it in half.
It bisects angle BED. So CE. Everybody look up here. I'll let you write it down after we're done. What does this mean? It cuts it in half. So what does that mean about these two angles created here? So this is congruent to that.
Mm-hmm.
So as my second step, I could say angle BEC is congruent to angle what?
ECD.
DEC?
Sure.
Now, why is that true? Definition
Of
of
bisector.
of angle bisector, right?
Then can we do CE equals CE? Common side.
Yeah, you're right. And see, right here, all I did though is I kind of went from here. What does that tell me? I wrote that. You see kind of the logic there? What did that tell me? It tells me that. Now he said he just looked at the picture and he saw a common side. So we can say that CE would be congruent to what?
CE.
EE.
And that's because it's a
Common side.
common side. Makes it the reflection property.
Then wouldn't they be congruent right there? Or angle side angle?
Yeah, angle side angle.
Then I could say, since they said that these two are right angles, angle BEC is congruent to angle DEC.
You already said that up there. Step 2.
Oh, I'm sorry. What I meant to say, I was going backwards. The two right angles are congruent, aren't they?
Yes.
Yeah, BC.
So angle ECD is congruent to angle ECB. And what can I say there? How about all right
Angles.
angles are what?
Congruent.
Now, if you noticed, I've said an A, have I not?
Mm-hmm.
I've said S,
Side.
and I've said a what?
Angle.
I've stated an A, an S, and an A, so I've stated three things that I need. The question is, I know that these two are congruent. That triangle
TCE.
ECB is congruent to triangle what?
ECD.
ECD. The question is
Angle side
it
angle.
angle side angle or angle angle side? Well,
Angle side angle.
these are, all you gotta do is that common side the one in between the two angles or outside the angles?
It's
It's in between, so it makes it what?
Angle side.
So in a way, that's not so bad, is it?
Mm-mm.
Well, why did you?
Keep going on.
Like on step 4, why did you basically like redo the angles names, like, you know?
Because I wrote down the same thing I wrote up here. I wrote the wrong name.
Well, why'd you have to do that step all over again? Or does it matter how you name the angles?
Well, all I set up here is that those two were right angles. I didn't say they were congruent.
Oh.
I need to
okay.
physically have a congruency statement. I need to say, so that's why I said over here, okay, I said my physical congruency statement, so I've now stated that they're congruent, so that's why that's one of my A's. See how I physically stated, or I wrote down that they're congruent, not inferring. Does that make sense? I mean, I know when everybody looks at that, oh yeah, they're congruent, they're right angles. But we still at some point need to write down and show that they are by writing the actual congruency statement. Make sense? See, once I've written all three of those down, I've established the three things I need to say that they are congruent.
So basically, like step 2 and step 4 are almost the same thing. It's just step 2 is congruent because of a bisector.
And these are congruent because they're what? Right angle, both right angles, all right angles are congruent. It's just why are they congruent?
Yeah.
And once you've established that, you've given a reason why you can say that's true. You've said those three things true, now you can say they're congruent.
Okay.
You said that's number 6.
Grid paper is good for drawing triangles. I need to make some more and make it lighter. It's just really good for drawing decent triangles. We're gonna do, kind of maybe start number 7. And then we've got to get on to the next one. Next section.
We're learning a new section today too.
But it's super easy.
It's super easy.
Well, it's supposed to be
Okay, what's given to us here on number 7? It's given to us that angle W is congruent to angle Y, and that WZ is congruent to YZ, and that XZ bisects angle WZY. That is all given. Now, where some mistakes might be made, we've kind of gotten on a roll, and what's kind of the first thing? It seems like everybody always writes down. What do we see right now? A what?
Common side.
Common side. So you come down here and you say XZ, because that's a common side, right?
Yes.
Is congruent to what? XZ. Common side. Okay, we're in good shape there, aren't we?
Yes.
And you look up and you say, wait a second, I got 3 things written down, don't you? You have a angle here, you have a side, and you have a side. Are we ready to say that these 2 triangles are congruent? We have 3 things.
No.
Why no? Because you, by the tone of my voice, or because you actually see?
The tone of your voice.
Okay, that's at least you're observant. The tone of my voice is leading you to say no. But what I want you to know is why no. Look at what you're given. Look at it one triangle at a time. Look at the triangle on the left and tell me what
We don't have like a.
Oh, we don't have.
what are your possibilities? Remember, your possibilities are side,
That's-
side,
that's
side,
ASS.
angle, side,
Yeah, that's.
angle, side, angle, and angle, angle, side.
It's ASS.
I've been given the situation that makes a cuss word, haven't I?
Yes.
This is the angle outside the other 2 sides, correct? So it's angle, side, side. That doesn't work. So I don't have what I need yet, do I? So I've got one other thing to try to find. Well, what other bit of information was given to me besides the common side and besides the 2 they gave me congruent?
XZ bisects.
That might have something to do with, it might be important, huh? It says XZ bisects what? WZY. What does that mean? It then means that this is
WZ.
congruent to what?
That.
Agreed? So I can now say angle WZX is congruent to angle what? YZX?
That side angle.
Y, definition of what? Angle
Bisector.
bisector. Don't just guess. Now, I've got another A. Now do I have enough information?
Yes.
When anytime I have 2 angles on the side, I have enough information. But can I say it's one of those theorems yet?
Yes.
Well, it's this angle, this angle. Let me ask you this.
Side angle, side angle. I mean angle, side angle.
Tell you this much. Triangle XWZ is congruent to triangle XYZ. And if you guys can, anyone who can tell me in the next 10 seconds all the possibilities for your reason for number 4,
Ooh. Angle, side, and that's it.
Nope.
Darn. Was I close?
let's say you ignored that one.
Oh, angle, angle, side.
That's angle, angle, side. Let's say you ignored that one. That's angle, side, angle.
I said that one.
Let's say you ignored that one. What is it?
Side, angle, side. I said that one
Side, angle,
too.
side.
So, any one of those three will work, because you've stated four things now. So there's a bunch of different possibilities, isn't there?
There's three.
So you can say side, angle, side. You don't have to write all this down, I'm just writing it down so you have it. Or you could say angle, angle, what? Side. Or you could have said what? Angle, side, angle.
So I was 2/3 right.
Yep, very close.
Good job, man.
The only one we couldn't say is what?
ASS.
No. What's the only
Side,
one
side,
left?
side.
What's the only one of the four we've learned?
Oh,
Side,
side, side,
side.
side.
Side, side, side. That's the only one you couldn't say. But if you'll notice, you could get rid of one of the four and have that's either one of those three situations. Okay?
What were we trying to prove? Oh, never
The
mind.
two triangles congruent.
Mhm. Yeah.
I'll tell you what, let's finish this stuff up. No, we gotta do 4/6.
Dang.
We've got to.
What are we doing tomorrow?
Reviewing for the test.
When is our test?
Friday.
How many proofs will be on this test?
None.
Yeah.
Yeah.
Buddy,
I don't think so, unless I change my mind.
Dang.
Don't change it.
guys, be quiet.
I could change my mind now. All right, let's start 4/6 now. 4/6. What is the title of 4/6?
I don't know, I gotta get more paper.
Isosceles and equilateral triangles.
Isosceles and equilateral triangles.
Okay.
Okay. Here's an important thing. An isosceles triangle the two sides that are congruent are called your legs.
What are they called?
Oh.
The side that's not is called your base. These two angles right here are called your base angles. That angle right there is called your vertex angle. So the vertex angle is where the two congruent sides meet, right? The two congruent sides are your legs. The two angles that aren't, two other angles are your base angles that together create the base. Yes.
Put it that way.
Vertex angle. It's,
Whoa.
Are there gonna be proofs in this assignment?
no. This is also is something you'll use over and over again as well. Isosceles triangle theorem. The two sides in a triangle are congruent. Then the two angles that make or that are opposite those sides will always be congruent. In any triangle, if two sides are congruent, what two angles do you think are congruent?
The
Uh,
common.
BC.
Angle BAC and CBA.
B and C will be congruent there. If those two sides are congruent, then those two opposite angles have to be congruent. If you think about which ones are the opposite angles, well, wouldn't it be the ones that the two congruent sides make the vertex angle? Basically, your base angles are always congruent. Does that make sense?
Yes.
The two angles that are kind of opposite the sides, not the one that the angle the two sides make that are congruent, but the ones opposite each other. No matter how I draw it. And I'm going to put on here and vice versa.
So if the two angles are.
If the two angles, draw a picture. If this angle was congruent to that angle, what two sides do you think are congruent?
BC and AC.
Right? No matter how I draw it. In this case, which two angles are congruent?
A and C.
Something you gotta always remember. Very useful.
Plus C.
If the two angles are congruent, then the two sides are congruent. Which two sides are congruent there?
AB and AC.
Right?
Uh,
Is that okay? You guys get that?
Not really.
It's
Now, these two angles are congruent, right?
so two sides have to be congruent.
The two sides that meet there have to be congruent. And most of the time they'll draw it to scale, you'll be able to tell, it'll be pretty obvious, but when they don't make it obvious, how about there? Which two sides would be congruent there?
X,
X,
Y,
Y,
and
X,
X,
Y.
Y. Oh, never mind. Oh, now I see. Okay.
See how they're opposite each other? Look at all these I've made. The two sides that are congruent, they meet at the non-congruent side, don't they?
Yeah.
Look at it every time, no matter how I draw it. The two sides that are congruent meet at what? The non-congruent angle. And you see why the word opposite does affect these angles. The opposite angles are the ones that are congruent. Make sense? That's the isosceles triangle theorem. If those two sides are congruent, then the two opposite angles are congruent. Well, of course, equilateral triangle. Equilateral triangles are easy peasy. What do you know about an equilateral triangle?
all of them are the same.
All the sides are what?
Equal.
Okay. You don't have to write this down. A, B, C. If this is congruent to this, it's congruent to that. With the isosceles triangle theorem in mind. Don't worry about AC, worry about these two here. What two angles are congruent now?
A and C.
A and C. That would be congruent to that. Now turn it around like that.
Like what?
Oh, like that. What two angles would be congruent now?
C and B.
So what do you think in an equilateral triangle, what do you think about all of the angles?
All are equal.
They're all equal. Now, what do we know the angles inside a triangle have to add to?
180.
180.
So what do you think in any equilateral triangle, what do the measure of the angles have to be?
180.
60,
Oh, yeah.
60, 60. Because that's the only way to split 180 up three equal ways. You divide 180 by 3, you get what?
60.
So in an equilateral triangle, all the sides are equal and all the angles are what?
Equal.
But what you more know is that all the angles have to be what size? 60 degrees, right? Any equilateral triangle, there's no other way to draw an equilateral triangle. All the angles have to be 60 degrees. Okay? So with that in mind, if we weren't thinking of non-proof type things, 19 on page 290. This, of course, is in your assignment. What type of triangle do I have?
You have
Equilateral.
Equilateral. Have they given me some things that look like algebra?
Yes. So
Yes.
you're gonna make an
So
equation.
you're probably gonna make an equation. Equilateral, basically, everything's equal. The sides are all equal, the angles are all equal. So what do you think your equation is going to be here?
2x plus 11 equals 6x minus 9.
Would you guys agree with that?
Yeah.
Not too
Then
bad.
solve.
Now though, what in the world are they doing to us right here?
They scared me.
well, right
it's a,
triangle.
isosceles triangle.
This is a right triangle, there's no doubt.
Oh.
So angle
There's,
E and
there's
angle
no
G.
doubt, okay?
It's also an isosceles.
But, did you wake up? This is a right triangle, so I know that this is 90, correct?
Yes.
So the other
What
one.
have I learned about when two sides are congruent in a triangle? What do I know about the angles connected to it?
Angle
They're
E and
also-
angle G are
So I know
same.
that this is congruent to
that.
what?
That.
And if
So if that's 90, what's left for both of
30.
these to be?
30,
30.
Might be
Isn't there 90
close.
left out of
45
180?
and 45.
45.
Yeah, I like
So this one has to be what?
Now it's following.
45.
This one has to be what?
Equal to 45. 30. What?
Would everyone agree?
Yes.
So those are both 45. So now what kind of equation am I going to make?
3x plus
3
6 equals 45.
3x plus 6 does equal 45, does it not?
Yes.
You can solve that then, right?
Yeah.
So you see how they kind of
It's
changed it up a
13.
little bit on you?
Yeah.
So the other one, need to know about equilateral triangles. This one, the key to getting this problem was knowing that that had to be congruent to what?
That.
Because they've stated that those two are what? Congruent. And then if that's 90, there's 45, 45 left there. And you know that 3x plus 6 has to equal 45. It's not so bad.
No.
What about a problem like 22?
What about it?
You know that it's equal 60 because the other two are 60 and
It's
they're
equilateral.
But yes, but does the x have anything to do with the 60? Or does the y have anything to do with the 60?
No.
No. I don't think.
no.
No.
It is not. It's an equilateral triangle. You have
No,
this-
but how does the 60 help you?
It'd be
It
2y
means
plus
that
x.
angle L is 60.
I mean, I can look at this, and I'm sure all of you say, hey, it looks like all the sides are equal there, doesn't it?
Yes.
But is that enough information to say it looks like it?
No.
No, we've got to have a reason. Now, this is 60, this is 60, there's 120 degrees used up. How many does that leave out of 180?
60. If all the angles.
Now that I know all the angles are equal, what does that tell me about all
It's
the
an
sides?
equilateral.
The
They're all
sides
the
are
same.
Now, it leads me to two equations. I know that 2y plus 6 has to equal what?
5x
I could
minus
say it
3.
equals 5x
Or
minus
you could say it
3,
equals 4.
but would that do me any good?
No.
But I can also know that it's equal to,
4.
so I could find y, couldn't I? But I
Yes.
can also say that 5x
Y equals
minus 3 equals
1.
what?
Four.
It also must equal 4 because it's an
Equilateral
equilateral triangle.
Yeah.
Now you've established what you need, and it's just a matter of solving it. Quickly erase that so you have to think about it again.
I already
Do
got
the
it.
problem.
I forgot what we just did.
I wrote it down.
See, like I said, this one isn't too bad. Those are the hardest problems in the whole drill.
What?
Dang, those are easy.
Okay?